Hello, everyone, and welcome to Particle Physics for Teachers. It's great to have everyone joining. Thank you very much for taking part in this course. I'm Michael Gregory, the host and creator of Particle Physics for teachers, not of particle physics in general as a concept, of Particle Physics for Teachers. And I'm really excited to be starting this off. As you hopefully noticed in the email I sent today with the Zoom link, there's been a change of schedule. So Anja Horvat's Introduction to Particle Physics and CERN is being switched to Thursday when I was going to do my Introduction to Particle Physics in the Classroom and Beyond. So I apologize for that last minute switch. I also apologize that it's been a bit of a rush, me getting ready to present this today, because I was expecting to do it Thursday. But all of the ideas have been in my head for months, so hopefully things go well. As you're starting to join, if you haven't done so yet, please say hello in the chat, say where you're from as well, both because it's interesting to see that, but also anyone who wants me to keep track of an attendance to give you a certificate at the end of all the courses, then I need some kind of record that you've been here. So please don't be shy and say hello. It's great to see a number of you have your cameras on, so I can see there's real people I'm talking to. If you're not shy and if you're not with a limited data connection, then I encourage you to keep your camera on so we can see each other. But if for any reason you're not able to or don't want to, of course, you don't have to. So going over the plan for today, there's a number of things I want to go through. First of all, welcoming everyone, so welcome again. A couple things about how the course will run, an admin, then going through why I'm running the course, why you guys are here, or why I hope you're here, if anyone has any goals to add to that, the schedule for the course, and then how we can use particle physics in the classroom, beyond the classroom, and a couple of things like that. So hopefully that sounds good to everyone, because that's what the plan is. So a couple of things, as I've mentioned, but people keep coming in, so I'll mention again. Please say hi in the chat. Like I mentioned in the email, please feel welcome and encouraged to discuss at any point. Both anytime you want to throw something in the chat, please do. But if it's a discussion time, so most of the sessions, there will be a guest, either a guest educator or guest scientist. In that case, sometimes they don't like to be interrupted. Wait until the end when we're discussing things more. Me, I'm a teacher, or at least like my background and 15 years of experience is teaching. I'm used to being interrupted. I actually like it because it shows that people are paying attention and they have something they want to talk about. So please feel free to interrupt me anytime when I'm talking. Today, I'm the only one doing it, so please feel free to interrupt me at any point. Then a couple of things, and the two last points I kind of have on that list. There's an extreme amount of diversity, and we'll get to that when I get to the part like who you are. But a lot of us have very different backgrounds, both where we're coming from, our comfort with English in some cases. Hopefully I'll be speaking slowly and clearly enough that everyone can follow along. If I lose track, get excited, speak too quickly, tell me to slow down. If anyone has any questions in French, Italian, or Spanish, I can field those as well. I can attempt to do other languages, but it's kind of limited to that at the moment. But especially, there's a lot of us either who have absolutely no experience with particle physics. I tried to make that clear in a lot of the invitations, that it should be accessible to people who have no background whatsoever. But there's a lot of people who know a lot more about particle physics than I do as well, and I'm the one running the course. So there's all kinds of different levels. Be patient, share with others. If you're one of the people who has a very high level, hopefully being a teacher, because this is a course for teachers, hopefully you like teaching and you'll join in and share some of your expertise as well. But if you're an advanced physics teacher looking for a highly advanced course in particle physics, I'm sorry, this isn't the perfect one for that. It's more of an introduction or a refresher or a forum for us to share ideas as well. Because I'm hoping seeing some of the people who've signed up for the course, both knowing some people personally and seeing some of the people who've signed up. I'm hoping that I'll be able to learn from a lot of you guys as well. And it won't just be me or the wonderful set of all-star guests that I've invited along. So that being said, I'm going to spend a couple of minutes, probably between 5 and 10 minutes, kind of explaining why I came up with this course in the first place. A number of you, I think, probably already saw my Scientix webinar last week. Some of you didn't. There's going to be some crossover with this introduction, but I'm going to go into a couple more details on why I think this course would be useful or how I ended up creating it. Like I said, if anyone has any questions about anything I go through, please feel free to interrupt. Or if you have thoughts you want to add, an interruption is always an invitation to talk about something at least one person is more interested in. Okay, so a couple of things. As a lot of you know already, I'm the French ambassador for Science on Stage, which is one of Europe's largest science teaching networks. Their motto is "From Teachers for Teachers." I'm also a French ambassador for Scientix. Those who you know both networks, you'll know there's a heck of a lot more Scientix ambassadors. There's 1,000 and something at the moment. Both are great networks, both from learning from each other, getting new ideas and getting messages out there. And then I'll talk about a couple of different projects that led on to this. So the first one is in 2020, like almost all of you, maybe not all of you, maybe there's some exceptions, but in France, with the COVID pandemic, schools were closed. We weren't teaching anymore. And I missed doing experiments. So I came up with virtual science camps to encourage kids to do experiments with materials around the house. For a lot of reasons that I'm not going to get into at the moment, I tried to get as many people from around the world joining in as possible. And as you can see from like the one pie chart there, then often I'd have kids from 10 or 20 different countries in the same session. And so it was a great way of having like a more international class than I'd ever had before. Like everyone else, I was really glad when the pandemic started tapering down and we were able to go back to in-person classes. But I also really missed the idea of being able to reach kids in 20, 30 different countries at a time. And so I racked my brains to figure out what was the most interesting element of the virtual camps and how could I do something that remained interesting even people could do experiments live in person. And so I gathered my most favorite guests who had joined me for those sessions and ran a series of virtual science camps. Oh, that's the rerun. First, particle physics for kids. And the idea, which is the idea for this course, which is the reason why I'm repeating this story, even if you've been on a webinar or some other course where I've explained this story before, this is essentially the idea behind a particle physics for teachers course and to encourage people to use particle physics, even in non-physics topics. Yeah, the idea was, if we try, then with scientists, with teachers, with me coordinating everything, we can have some elements of modern science that can be accessible even from a very young age. So that more than anything else, that's what I want to transmit from this course. That went well, so I reran the course the following year. And by the end of it, there were more teachers than students. So I thought I need to do this for teachers. And it was a long time in the making, from spring 22 until now, a year and a half later. And there's a number of things that kind of came up that added to the richness of what hopefully we'll be seeing. So one of the things that came to be, Steve Goldfarb, who's our guide for a virtual visit of the Atlas Detector next Friday. The reason it's a Friday, I'm assuming that's not a good day for many people, but that's one of the only days for Steve that worked that week. There's a lot of reasons for that. one is that I was intending on being there in person for it. I'm not going to be there in person in the end, but anyways, that's why it's on a Friday. But Steve is one of the most amazing people I've met. I can honestly say if it weren't for him, I wouldn't have rerun particle physics for kids, and I wouldn't be organizing this course now. 2022, no, 2021. So kind of second year of the pandemic drawing out. Things were starting to open up. From France, at least, we were able to travel a bit more. I had planned a return trip to Ghana, where I've gone every year to run workshops for teachers. And last minute, there were new travel restrictions. It was canceled. I was really disappointed. So what I did with that, I decided school break, I'm not allowed to go anywhere. This sucks. I'm going to do something interesting. I'm going to come up with what I called a virtual museum pass and have a set of virtual camps where I'd have people from museums show kids around museums that were closed due to pandemic restrictions. That idea didn't work at all, but it led to me getting in touch with a whole bunch of people at CERN for their virtual visits, including getting to pilot their new set of virtual visits of all of the facilities they developed virtual visits for. But Steve, by chance, and this is an amazing stroke of luck, except luck happens where people try hard as well. And Steve is such an amazing guy. He always keeps his eye on the page of requests for Atlas visits, and he'll often be the first one to volunteer. So as soon as I had requested, later on that day, I get an email from Steve who says, "Oh, I'm happy to be your guide, but this sounds like an interesting project. Would you like to present it at the weekly Atlas meeting next week, the Atlas Outreach meeting? Would you like to present it to the International Particle Physics Outreach Group?" And eventually, a year later, he invited me to present at a conference he was mediating at the American Physics Society to give a teacher's perspective. All of this kind of makes sense when I explain that a teacher's perspective, what I gained from presenting that session was really a sense that scientists are disconnected with teachers. Not all scientists, but a lot of scientists. And they have the typical problem that most of you will probably experience in your country anytime there's education reform, where there are politicians deciding what should go on in schools. And politicians and pretty much any adult assumes because they have experience going to a school as a student, they're an expert in school or they're an expert in education. So you have all kinds of decisions being made by people who have no experience teaching. And outreach and classroom activities made by scientists and research institutions often fall into that same. So just by chance of being in the right place at the right time, being a teacher willing to share a teacher's perspective, then I ended up meeting a lot of scientists who were very eager to meet teachers, as if there's a shortage of teachers available, interested in sharing what they're doing. But this led to a lot of ideas that this course, and this is really what I'm hoping to offer with this course, is led both by teachers and by scientists, whereas anything else I've seen has either been led by an institution and the scientists there without much of a teacher's perspective, or by teachers, and they might miss out on some of the advanced science perspective. So that was kind of the idea of that part. But that's enough about me. Now, who are you guys and why are you here? And I have some ideas, but I'm interested in hearing more. So start thinking of any goals you have for the class, for the course. As I'm doing that, just to give an idea from the registration form, like from those of you who signed up, here's a couple of the stats. So there's roughly 20 countries. I think when I counted yesterday, there were 17 that people signed up from. But you may have noticed if you're one of the 19.7% who were on a country I didn't list, I messed up how the form was, and you guys didn't actually tell me your country because I didn't have the form set up right. So this other could be one country and everyone's from the same one, or it could be several. Who knows? Anyways, there's more secondary school teachers than anything else. There's a good representation of primary and middle school teachers and teacher trainers. And almost half of you have been on CERN teacher programs. So a lot of you probably have a good foundation in particle physics. Some of you have been on other courses. A lot of you have been on nothing in particular. And more than half of you have at least a decade of teaching experience. Now I'm interested. Oh yeah, okay, yeah. Now I'm interested, and like I was saying, if you have other goals or reasons for being here, other than the ones I'm about to mention, please either add those in the chat, or I feel like I've been talking at everyone for a long time. So if anyone isn't shy and wants to add anything, please jump on your microphone and add as well. Just once I'm done overviewing what my goals or what I hope you might learn from this. So I want to make a lot of modern particle physics topics more accessible, because often, I know at least in my own practice, I was intimidated and really didn't bring much into my own teaching. Like I mentioned before, connecting between researchers. And then I want to get everyone interested and having some fun and getting some new ideas into classrooms and beyond. So with that being said, what other reasons are some of you here? Can anyone please share, either in the chat or with your microphone, why are you here? What do you hope to learn? What do you hope to gain? Anyone have anything to share? If not, I'll keep going. But like I really am eager to hear what some of your learning goals are. I mean, I know in the Google form I've seen those, but it would be interesting if people hear what each other are here for too. Okay, thanks, Don. So I've covered what you're hoping to do. So same with Katrine. That's one of the ones bringing ideas into the classroom. And if anyone thinks of anything after and was just too shy to mention now, please mention it whenever it comes up. Okay, so now I'm going to go over the schedule of the course and what to expect for the coming weeks. Like I mentioned before, there will be a fair bit of crossover with this and the Scientix webinar I did last week. So I apologize for those who have been on both, but there's going to be a number of people here who haven't seen that background as well, and it's kind of useful to know what to expect. Just checking in the chat. Excellent. So yeah, mainly people interested in ideas for the classroom, and great to have a biology teacher as well. I think you're probably not the only one. And like I keep saying, modern science, there's a lot of crossover between different disciplines. There actually one thing related to biology that is not on the schedule yet, and I'm going to mention that when pointing to the schedule. So this is the schedule. There's one in the works for a PET, positron emission tomography virtual workshop with Sarah Schlo. Sarah, not going to try and pronounce her last name, Sarah at CERN, who developed a virtual PET module, has volunteered to share it during a session, and we're just trying to find a date. So that's a medical application of particle physics. There will probably be a session for that. Like she's agreed to present that session. I just haven't written it on the schedule yet because we don't have a date. If we don't end up finding a date, then don't say I was lying. I'm saying it's tentative, but tentatively she's agreed to that as well. So you'll see, like, through the overview of the schedule, it's about half and half, scientists versus teachers, depending how you count some people. So in the case of like Dave Fish, 2 weeks from now, from the Perimeter Institute, he's a teacher in residence, but at the Perimeter Institute for Theoretical Physics. So you could say, well, okay, that's a science institute, but showing educational resources. Similar with like the CERN educational resources, the team there I think everyone presenting that time, they're PhD students in particle physics. So more of a scientist point of view, but classroom activities are more of a pedagogical thing. The others are the others are more clear, which kind is which. So Anja, who was going to present today, but now switched to Thursday, she's going to be overviewing particle physics as a whole and CERN, including the history of CERN. And I've mentioned Anja a lot before. She's been a great mentor to me, not only for science performance and coaching me to make my first science show and to make Particle Detectives, which is a show that she's my boss and I'm selling it to her, I guess is how you could describe that arrangement. But she's also an authority in particle physics in the curriculum. As a follow-up to her thesis, she published a paper last year that was a survey of particle physics and non-particle physics topics in 27 different curricula. I was going to say high school curricula, but some of it goes down to middle school. In 27 different countries, she covered most of Europe. I mean, there's some countries that are missing for various reasons, or they have similar curricula to the other, but it's by far the most definitive guide to what particle physics is taught across the continent and to an extent beyond. So she's an excellent resource for that. Steve, who I already mentioned before, will be giving the Atlas virtual visit at the end of next week. Marco is going to be giving an overview of detectors and how to use bubble chamber traces, which was where I first kind of learned how to make sense of traces, or how, like, he was great at teaching me that. Jesus in Madrid, who's the outreach director of CIEMAT, which is I was going to try and remember the acronym in Spanish, but it's a national laboratory, a national research center. And you can see me there in the center of the picture. Welcome to their physics school, summer school. And you see him with the Muon telescope there. And that's an example, well, that's an example of a sub-detector from CMS where Jesus has worked for well over a decade. And he helped design that component. But seeing that in detail was one of my first times understanding the details of how a gas detector works. I just never bothered looking it up or thinking about it in detail. And so that's one of the reasons why I chose him, and I asked him to present on this course as an example of a sub-detector and what, like, specifically a gas detector can do, and like the science behind how it works, because there's a lot of non-particle physics specific ideas in there, like electric fields. When you have a charged plate and a charged wire, then if there's an ionization, there will be a migration with a certain time, and it's the drift time in the detector that allows you to detect where within the drift chamber the particle caused ionization. So that, like, once you look at the details of how any given subdetector works, a lot of it is high school physics, but it's applied in fairly interesting ways. Then a homemade version, not of like an argon drift tube from CMS, but of a gas detector with Federico, who's another amazing teacher. So this is one where when he showed me this in July, so I visited Federico in July, I was amazed by it, and I immediately wanted to make my own, but I've been traveling a lot since then and haven't gotten around to it. So not only am I looking forward to, like, Federico sharing this with everyone in the course, but I'm also really looking forward to him talking me through it and to take the time to do that. Then finishing off with a couple of last ones. Claire is the only host who I haven't personally met yet. but I've exchanged with her, and she's up to some pretty amazing stuff. One of her most popular talks, because in addition to being a professor, in addition to doing outreach across Africa, like she traveled in 8 different countries last year on a sabbatical year, doing all kinds of outreach. And on top of all of that, one of her most popular talks is on the discovery of the Higgs boson, which is a good way to finish off the course, like scientific talk. And then, of course, finishing off with more educational resources. Oh, and I realized I didn't have a slide for Dave Fish from Perimeter, but similar idea to the CERN educational resources, except I actually prefer the Perimeter ones. Those of you who have experience with different resources for either for particle physics or, Perimeter does all kinds of physics and science in general. Perimeter, they, I got stuck for words there, but one of the things they do, so I was mentioning that there's a disconnection between scientists and teachers. And Perimeter is the best place in the world that I've seen for bridging that gap, where they have long-term teachers and residents like Dave. Dave has been a teacher in residence there longer than he's actually been a teacher. But for his first decade or so there, he'd spend 1 year at Perimeter, 1 year in the classroom, 1 year at Perimeter, 1 year in the classroom, so that he'd always be in touch with what it was like teaching. But he became an expert in creating modern physics resources. And he's not the only person. Like he's the person I most admire like that, who I invited to share Perimeter's resources with you. But they've got a whole team of people who are similar minded there. So it's definitely worth checking out Dave's session, which there's not a slide on that, but it's the 7th of December that he'll be sharing Perimeter's resources. So now we get to one of the actual, like what this specific session, other than welcoming everyone and overviewing. And it's how does particle physics fit in the curriculum, both in a particle physics topic and a non-particle physics topic. And again, I feel like I've spent a long time talking. So now it's up to you guys. First of all, in the chat, but if you have anything that you also want to describe in more detail than you want to write, please jump on your microphone. But please share with us what, if anything at all, do you teach about particle physics? So some of you are teaching like a course that has a specific particle physics topic. Some of you not. Those of you who aren't, you might bring particle physics in, you might not at all. So take a couple minutes. Hopefully, at least a number of you will share some of the ways that you already teach particle physics. Okay, we're starting to get a couple of answers, like in AP courses, some standard model. Different parts of the atom. Does anyone have any favorite lessons or any favorite topics, like a strategy of how you do it? Okay, thanks to everyone for sharing. So, oh, and a couple more things coming through. Okay, reading all the answers, it seems like there's a lot of related things to the atom, and then some introductory cosmic rays or cyclotrons uh, and accelerators, but not a lot of detail that's gone into, especially if it's not included in a program. So that brings me to the next question. Then how, if you do it at all, do you include particle physics in non-particle physics topics? And take a minute to think about that and share any ideas, and then I'll share a couple of ideas that I have as well. Okay, because there might be a little bit of wait time if people are thinking ideas, or maybe people just don't have that many ideas. Then I'll give a couple of okay, maybe I wasn't clear with the question as well. So maybe once I give an example or two, it'll make a little bit more sense. So in most countries, introductory physics, somewhere like it at the very beginning, usually when students are somewhere between like 12 and 14 years old, there will be questions on speed, distance, and time, like sometimes even younger. But you'll be given questions like, if someone walks 10 meters between classes and it takes them 4 seconds, what's their speed? And then you calculate distance over time. They're traveling at 2.5 meters per second. Like that comes up as a non-difficult introductory physics topic. And it's possible to bring in examples from particle physics. For example, you could give a question: the Large Hadron Collider is 27 kilometers in diameter. Particles are traveling around it at nearly the speed of light, roughly 300,000 kilometers per second. How long does it take for a particle to go around the LHC loop? And that's just a simple speed, distance, and time problem that can be brought in introductory physics and already start seeding the idea, we can use these calculations to understand something about big laboratories. Similarly, you could use stats like the Atlas detector is 42 meters in diameter. How long would it take a daughter particle traveling at near the speed of light to go from the beam line near the center of the detector 21 meters to the outside of the detector if it's traveling at, and then you might want the speed of light in meters per second, so then 300 million meters per second. So just with the speed, distance, and time, which any introductory physics course, like very basic early level, needs to cover, it's possible to start bringing in examples from particle physics. And yeah, now I'm seeing the chat, people are saying, oh, well, then you can start including it in pretty much any topic. And if you just look for where it can apply, if you get to more advanced things, then one of the big things that people are looking at with particle traces, and in one of the later sessions, we'll look at how you can use LHC data and you can look for daughter particles. Like there's great activities looking for the like a ZZ decay, looking for the Higgs. Then you're keeping track of momentum. So in like a medium introductory physics course, like in most countries about 15, 16 years old, then collisions and momentum come up. So the idea of conservation of momentum, that can come up there. Same with things like electromagnetism. So Louisa was mentioning that in televisions, for example, a cathode ray tube, that's a very early particle accelerator. It accelerates electrons. It's not putting it at a target where you're looking at nuclear reactions, but electrons are smaller than the atom, and it's accelerating electrons down the end of the tube. So there's all kinds of places where it can be brought into non-particle physics topics, and that's one of the things a lot of people don't realize until it's explicitly mentioned, that it's possible to use modern science, not only modern physics or not only particle physics, but it's possible to use modern science in all kinds of places. The other thing, and what a lot of people might have thought of before this, is also where can we use particle physics beyond the curriculum? And there's a couple of different, well, I mean, there's near infinite number of ways you can do it when you're not limited to what you need to do in a program. For example, myself, and some of you will be in the same situation. Like if we go back several slides to who you are, roughly half of you, at least based on who signed up, maybe not who actually showed up, but roughly half of you have been on CERN teacher programs. And some people who signed up have been to LIGO, a handful have been to Perimeter's Einstein Plus course. So if any of you are like me, then when you got back from a program like that, you thought, well, okay, how can I share this with my students? And you can think of how I can do it in class, but you might do things beyond class as well. Like the year after, I went both to the Joint Institute of Nuclear Research in Russia and to CERN's International Teacher Weeks. Then I founded a particle physics club at my school. And that was easy because I didn't need to focus on how this relates to the curriculum, didn't need to make use of class time for that. So that was one way that I did that. My most exciting one, which I'll talk about in my next slide, is my low-cost particle physics show. Let's see if anyone has any examples of ways that either you could or you have shared some part of particle physics, not only at your school, but like with someone, whether it be your school community, your students, your friends, a spouse. What's something you've shared about particle physics that's not part of a curriculum or a school program? Are there any ideas people have to share? And I guess I have a slide for that. And oh, and I mentioned bad as well. So while waiting for people to give answers, the idea of sharing bad experiences. I was talking a week or two ago with Wojtek Pleskot, who's a particle physics in the Czech Republic. Anyone who joined me for particle physics for kids, and statistically, most of you probably wouldn't have, just with the numbers and stuff like that. So most of you have no idea who I'm talking about, but absolutely wonderful particle physicist. He did a great session on radiation around you and PET, like Sarah's going to do for the virtual PET lab. He did one on medical imaging. So it wasn't positron therapy, but it was tomography to image. Anyways, we were talking about how scientists doing research, how it can be useful for them to share what works well. Like if they run a course, or if they do a lecture, or if they're presenting at a science festival, to share what works well and what was successful. And then it came up, I was saying, we could also learn from how people failed and what didn't work. And we agreed that it would be great if people were sharing more outreach failure stories to tell people what to avoid, but that often people were embarrassed, or especially how it works with science. And I touched on this before, but I'll I'll mention it again because it's a key point. A lot of scientists who come up with education programs or like yeah, a lot of science institutional based outreach and education, that follows a scientific model where the person creating the activity, they need to impress their supervisor, and their supervisor or them directly needs to impress funders, and that's how they continue to have a job, or that's how they get their outreach paid for. But that leads to a system where they're rewarded for something that looks good to someone, either a supervisor or a funder, who doesn't bother actually trying out the activity. They just hear about it, or they just see it on the surface. But it doesn't reward an activity that actually works well with students or actually accomplishes learning goals. And it comes up in a lot of cases that it's actually disadvantageous to evaluate how well the activity accomplishes learning goals, because there's the possibility that it might not accomplish it as well as it looks if you just present the project to a supervisor. And so that's one of the reasons why there's a lot of outreach coming from a lot of research centers that's actually less good than it could be. So some of it is outright bad. So in a lot of ways, it's useful to share failures as much as it is to share successes. And while I was going off on that tangent, I see a lot of people have added things to the chat. So I'm interested in hearing everything people have shared. Also, if anyone isn't shy and they feel like talking and sharing their stories are always better when they're heard. So if anyone feels like jumping on their microphone and sharing something you've said, even if you've said it already in the chat, please feel free to take a moment to do so. And there's some good stuff that came through the chat. It doesn't look like anyone feels like actually talking and sharing a story at this point. But there were a couple of really good ideas there, including sharing with friends, sharing on social media, inviting scientists to speak to students, taking them to research facilities. I know from experience that actually both bringing scientists to students and bringing students to scientists and facilities, that definitely is a huge motivation factor. So that's something I definitely recommend, even for students who aren't studying that specific subject. Like I remember one time bringing students to CERN, it came up that I was bringing my science club, and there were 12 students in the club, but we could fit, it was either 20 or 24 signing up for a school lab workshop at CERN. So I decided to open the invitation to anyone else from the school. And there were some students who just wanted an excuse to miss class and to go to Geneva. And some of them then end up becoming friends with the kids from the science club, joining the science club later and getting interested in science and going on to study science at university, just because they were welcome to join the trip and they wanted to do it because they wanted to miss class. So sometimes exposure is worth it, even if there's not a directly, like you don't see why or how that would be useful. So thanks to everyone who shared those experiences. Now I'm gonna overview my favorite new project for bringing particle physics beyond the classroom. And this is a science show that I've been developing. So there's a bit of a long story behind this one. It also relates to how, anyways, a year and a half ago, I took a big step to leave my school. The plan was to take a year off of teaching to teach myself science performance. And I was coached by Anja, who I've mentioned a lot, who's been a mentor to me, who will be leading Thursday's session. She works at CERN. And she coached me to make my first science show, to perform experiments. And it was a selection of experiments I'd learned from teachers around the world. At the end of that year, I was gearing up to start a PhD in particle physics outreach. And I had had a number of setbacks. I won't dwell on too many of the setbacks because that's kind of depressing, and who likes to hear someone just sitting complaining about things. But there were a number of setbacks, including retracted offers to work at different places in particle physics outreach. And so I started thinking, I need to take things into my own hand. I need to come up with a plan of how I can do interesting projects that, even if the next job I'm offered is retracted or doesn't work out, even if anything institutional doesn't work, how can I make something meaningful that I want to do, that I want to contribute to the existing knowledge of particle physics outreach? So one of them was to make a particle physics science show. But the problem was, I don't have much money. I'm just a teacher, and I took time off of teaching and haven't really been making much money. So I needed to make it as cheap as possible. So I was starting to plan how to make a really cheap science show. Meanwhile, Anja at CERN was developing her new science shows for Science Gateway, which is CERN's new public welcome center. They opened a month and a half ago on October 8th with 4 science shows that Anja's developed. So I was asking her for ideas, advice on what I could include in my low-cost show. And to my delight, she loved the idea. So she openly shared everything she was doing. And then as I was talking to her, her boss ended up overhearing some of the conversations and said, actually, that's something we could really use. There's a number of people, like members of CERN, who are going to be celebrating CERN's 70th birthday next year. They can't send all their people to Geneva. It's too expensive. They don't have the same budget that we do in their countries. So if we could have a low-cost version of our shows, that would be perfect. Can we hire you to write it for us? And so my response, of course, was, well, that's wonderful, but I was just doing it for myself. You don't have to pay me, but I'll accept any money you want. She said, no, don't worry, that'll be fine. I said, okay, but like, to be clear, the main thing is to be able to get it used by other people. So now we've been collaborating together on this show where, similar to my first one, Experiments World Tour, I've been using ideas from different teachers and science communicators from around the world. So the show itself is a model of international collaboration. I've tested it now in 7 different countries. And just earlier this week, I sent in the script for approval. There's probably going to be a feedback cycle where, I'll make changes. We'll improve it together. That's part of a collaborative, iterative process. But once everything's accepted, it'll be published on Science Gateway's website for any teachers, such as yourselves, or anyone else interested in using the show or using the experiments, the hands-on guide. I'm also developing a guide of how to make all of the experiments. So it's the guide, and the script will be available for free. I'd share the script now to show this what I have, but because it is going to be published in its final version before too long, I haven't bothered checking if I'm allowed to share it now, because technically it'll be their intellectual property, but it's going to be an open copyright, so I'm allowed to use it. Anyways, that's my most exciting project that I had. So with that, it's now been most of an hour. I've overviewed what to expect for the course, a couple of things, how to bring particle physics into the classroom and beyond. So we get to my last slide, which isn't that useful, because if you had the link, I already emailed you and you have my email. But if you have any questions or anything about the course, please be in touch. Hopefully, people might have some questions or some things to discuss. I'm happy to stay on if people have questions or want to discuss anything. But I'll get out of the slides. So if you haven't put me like big, you'll see me big screen, and you can see each other if there's anyone who has any anything they want to discuss or ask before we finish up. Any questions, feedback, or anything else?
Michael, thank you for your presentation. You know, I'm in South Africa, so we're far away from CERN, but we have a particle physics research facility, maybe about 60 kilometers from us. Not always easy to get students there, but one of the things I try and do is on an annual basis have a science week. And I would love to have this next year have 1 or 2 of the days with focus on particle physics. My question to you is, would you be willing to maybe contribute as one of the online speakers?
Oh yeah, I'd absolutely love to. Yeah. So please invite me, or let me know how to be involved for that. Also, if you're interested in potentially contacts for other people, or there's I don't know how useful it is or not, but I prepared a list of particle physics resources for festivals that I can send to you, or like I could share with everyone if people are interested for that. There's a long story behind it and why I need to probably remove the name of the organization who I prepared it for, who kind of retracted an offer to hire me. But this is a like a list of resources that could be useful for planning that kind of festival too.
That would be great. I'd appreciate it. Thank you.
Does anyone else have any questions or anything they'd like to share? And just on the topic of South Africa, you probably noticed Claire David, who will be giving the last lecture of the course. She's at the Ames South Africa Center right now. So we will have a presentation from South Africa.
Fantastic. Yeah, Eva and I were actually at CERN together in July, so that's where we actually met. So I also met Dr. Claire Lee there. So I have got contacts, but you in particular, being a teacher, you obviously come with a different angle. So I'll contact you via email just to ask you what you could possibly do. Maybe bring it down to a level that's more accessible for high school students. But yeah, no, we at UCT, we've also got quite a few particle physicists that are actually involved in the Atlas collaboration. So they're down the road from me. So yeah, there's definitely opportunities here.
Oh, that's
Thank
excellent.
You.
And it doesn't look like anyone else has anything else they want to ask or say. So we'll probably wrap things up there. Just before leaving, just a reminder. So Anja's session, an introduction to particle physics and CERN, will be happening Thursday when I was going to give this session. So same time, I'll be sending out a Zoom link for that, similar to this one. It'll be a couple hours beforehand, probably early afternoon, like 4 or 5 hours beforehand, pretty similar to this. Oh, and apparently I missed a question in the chat. Stravos is asking if I can answer the question. I'm sorry, it's been hard keeping up with the chat while looking at my slides and switching between things. So I'll try and scroll up to it, but if I don't find it, can you repeat the question again? I didn't ignore it intentionally. I just must have missed it. Oh, okay. If your students are allowed to participate in any part of it, good question. I like students, so theoretically, yes. The only reason why not would be if teachers are less comfortable sharing things, but there weren't a lot of things people were sharing anyways. Out of curiosity, what like level or age are the students approximately? Uh, 16, 17. Let's go with yes, sure, invite them along, but just warn them that the focus will be on teachers. So like content will be addressed towards teachers and things like that. But if they're particularly interested, sure, invite them along. And Vanya's asking if Anya's lecture will be recorded. Yes, it will, depending on, and this applies to all the sessions. I guess I should have mentioned this before, but it's kind of a vague answer. So it will be, however, with Anja and with all of the other guest hosts as well, then after the recording's been done, I'll give them the option of if they're comfortable with it being published. If they're comfortable with everything, it'll be publicly visible on my YouTube channel. If they're comfortable only with people from the course getting a link to it, it'll be uploaded with link only sharing. And if for whatever reason they're not comfortable having the recording shared at all, like two very concrete examples, actually, they both came from the antimatter factory. So you might have noticed, if you have a keen eye for it, one of the photos I used of Anja is her and I in the antimatter factory. She showed me around there in 2019, and we filmed a video from my YouTube channel. In the end, the audio was horrible because it's a very noisy place, and I should have had a better quality microphone, but managed to get around that. But just when it was ready to publish, then she had second thoughts and said, actually, because she's not a specialist on antimatter, she doesn't want her thoughts on it being publicly available for people to see. So that might happen with her or with someone else. Another example that came up in the antimatter factory, there was a virtual visit back in 2021 when they were first piloting their virtual visits with Sarah, with the PET. She developed that as well. And I think it was Dominique Bertoli, either that or Francois, blanking on his last name, the head of visits who was developing it. Anyways, they talked about one sponsor and they got the name of the sponsor wrong. And so they said they need to pull the whole video, and actually they're not comfortable with any of the visits being shared in that way. So things can happen. That's a very long answer to say, yes, the session will be recorded, and if all goes well, it'll be shared. But I'm not going to force anyone to make me to make me allow. It's going to depend on the host in each case. Anya's tentatively given her okay, but it'll depend how things come out. Yeah, so sorry for such a long answer. It's not a clear thing. Are there any questions that I missed? Oh, and excellent. Thanks to Zlatko for sharing the schedule as the answer to that question. Any final questions? It looks like that covers it. So thank you, everyone, again for joining in. And I'm looking forward to hopefully seeing all of you on Thursday for Anya's introduction to particle physics in CERN. So thank you again, and have a great evening, everyone.